Hi there, this is Shikhar. When labeling a large volume of data, the size of the images can be a major bottleneck. Let's say you have around 200,000 images of 3 MB each. Even on a good internet connection, downloading a single image to your browser can easily take up to 4 seconds. That means you are spending almost 110 hours on just downloading the images. We can compress most of these images to about 70% quality without noticing much difference. Doing this will keep the image size below 300 kbs, which means an image will take less than a second to load. This in turn reduces the total image load time to almost 27 hours, which can translate into huge savings. On the Mindkosh annotation platform, we automatically compress all your images when you upload them to our servers. All you need to do is click on this little checkbox when creating a task. However, for large volumes of data, connecting your own S3 account is a far more efficient way of creating a task. If you have around 200,000 images in your S3 account, it will take less than 15 to 20 seconds to create a task containing all of those images. But how can you compress the images on S3? The best solution we found is to use an AWS service called Batch Operations. It is relatively simple to set up and quite cheap. For around 200,000 3 MB images, it will cost you less than a couple of dollars to do all the compression. And since you can run a large number of batches in parallel, the compression can be completed within an hour. The solution uses a combination of 3 AWS services. The first one is AWS Batch. This is a fully managed batch processing service. You tell it what code to run and how much compute to provision, and AWS manages the rest. The second is AWS Fargate. Fargate is a serverless compute platform for containers, so you can run your Docker images with it without having to do any configuration. And the third one is probably something that you're familiar with, AWS Lambda. And this is a serverless compute service. You just define the code you want to run and how much compute to dedicate for the code, and AWS handles the rest. So let's see how we can combine them to do image compression. So the first thing you need to do is create a compute environment. So to create a compute environment, go to compute environments and click on create. We want the environment to be managed. You should enter a new name here. Okay, so the service role is something that you'll need to create. And I already have a role made up. You'll need to create a new role by going to AWS IAM. You will find the code for an example role on our GitHub repository. There's a link in the description, so you can go there and check out how to create this role. But once you've created the role, it will show up here and you can select it. So you have 4 options here. You have Fargate, On Demand, and 2 Spot versions of these two. Now I'm not going to go into detail about Spot instances here. They save you a lot of money, but in turn, AWS reserves the right to stop your execution at any time they want. So let's do On Demand Fargate for this experiment. You can leave this as default as well, and you don't need to set anything else. So once you create compute environment, your environment will be set up. I already have one enabled here. Do make sure that this says enabled. I think it takes some time to create one, and once it is created, the state will change to enabled. Now next we need to create a job queue. Now a queue basically allows you to prioritize your jobs and create dependencies. We don't need any of that for our compression. So if you want, you can use the default queue, but we like to use queues to keep different runs separate from each other. So let's say you're compressing a data set today, and a week later you want to compress another data set. It can be helpful to have them in separate queues so that you can easily filter out the relevant jobs. So let's create one. Let's leave all the other things default. Yep. You do need to select the environment that you just created. So for our case, it will be this. Select this and create. So right now you'll see it as creating. Again, when it's done, the status will show as valid. So do make sure that the status is valid before you continue. And the final thing we need to do in AWS Batch Services is create a job definition. So let's go to job definition, click on create, then choose single node, give it a name. Now execution timeout is the time after which AWS will automatically stop your job. So if you have an error because of which it might be running into an endless loop, it can be helpful to have an execution timeout. I think for compression, it depends on how much time you expect each batch to take. So for example, if you're expecting each batch to compress around 1,000 images, it usually takes about 1 second to compress one image, slightly less than 1 second. So 2000 seconds might be a safe setting for this, but you'll have to test this out. Other than that, set the platform time to Fargate. This is okay. Do make sure that the assigned public IP is checked on, because you need to pull your Docker image from the Docker Hub IO. So do make sure that this is checked. You need an execution role for this. You'll find the code for this on our GitHub repository. Moving down. Okay, so this is where you need to enter your Docker image. If you have your own Docker image, you can enter that as well. We have created a Docker image for you. You'll find its location in the description below this video. And all you need to enter here is the actual image name. You don't need to enter dockerhub.io or anything like that. AWS will automatically pull images from dockerhub.io if you have not mentioned the host. So once you've entered the image name, let's clear this up. So the way our image has been set up is it automatically calls a command, so we don't need to call a command. This is where you set up what kind of compute you want. So I think for compressing images, 0.5 with 1 GB is more than enough. So let's move down. Now, if you're pulling from S3, you do need to enter your AWS credentials here. So you'll need to enter your AWS key and secret access key as two separate variables in this. And when we set up Lambda in the next step, it will automatically pull the AWS credentials from the environment variable. Other than that, you can keep everything else default. Once you click on create, it will be created. Again, do make sure that your job definition is in active status before you move forward. Now the final thing we need to do is to create a Lambda function that is going to trigger the jobs to run. So let's go to create a function from scratch, give it a name, select Python 3.9. Now for permissions, again, you'll need a role that allows you access to AWS S3 and CloudWatch. I've included the code for this on our GitHub repo, so you can check that out as well. I've already created a Lambda function, so I'm not going to actually create one. So this is the Lambda function that I have here. Again, you'll find the code for this on our GitHub repo. Now, if you look into the Lambda code, there are a few things going on here. So essentially what we've done here is we've created a manifest file that contains a list of all the files we want to compress and attached a batch number to each one of them. So let's say you had 1,000 files and you wanted to run 10 jobs running in parallel. You would assign 100 files to each batch, and we put all of this in a manifest file on S3 so that our Lambda code can read it. And when invoking a job through this Lambda code, we will pass this batch number to the job. So our code inside the Docker image that is running in the job will pick up this batch number and only compress the images that are assigned to its own batch. So it's a pretty simple approach to processing all these files in parallel. Now let's look into the code and see what's actually happening here. So this is the number of batches that you want to run, and this should match the number of batches that you have created in the manifest file. For our test code, we have created 3 batches, so we are only going to run it 3 times. Let's give it a job name. It can be anything. Next, we need to mention the job queue name, video tutorial. You need to mention the job definition, and then you need to set a few environment variables. The first one is the job key itself. This will automatically be set for you, so you don't really need to change anything here. Do make sure that the batch key in your manifest file matches this. So it should be batch underscore and then whatever number it is. So these 2 keys define where your manifest file lives. This is the bucket and this is the location of your manifest file. These 2 keys define your output location, your output bucket, and the location where you want your output images to be saved. The final variable you can ignore. It essentially divides your images into different camera directories if they have a suffix, let's say underscore left, underscore front, and underscore right. Then essentially this will put images from the left camera into the left folder, images from right camera into the right folder, and so on. Do make sure that once you've entered this code, you click on deploy. This is a very common mistake that we've done very often. So do make sure that you've clicked on deploy. And then when you run on test, you'll see your batches running. So let's actually run this and see what happens. So run it. Okay, so it says that it started 3 jobs. So the Lambda's job is done. Let's go to jobs to check if This actually worked. Let's choose the queue that we created. Let's click on refresh. Okay, so it's in submitted mode. So it will take some time to first start the container and then to run the actual job, and then it will show as completed. So I'll just give it a few seconds and then come back to it. Alright, so the jobs are all completed now. So all of them say succeeded. It also shows the time that each of these jobs took to complete. And that is it. That is all you need to compress the images. Now, if you also want to create a task with these compressed images, all you need to do is enter the location of your compressed images when you're uploading the images and click on upload. Now, as you can see, the task is now created. It's really that simple and that quick. These were only 25 images, but even with 100,000 images, it doesn't take more than 15 to 20 seconds. So it's really super quick. So that's it for this video, and I hope this was helpful to you. Please do check out our labeling platform. You can find the link in the description below. We have a free plan available as well, so you can get started pretty quickly. Thank you.